Okay.
Great.
It says it's setting it up, but it might already be live. So thank you guys for all coming on here. I know that everybody has been extremely busy with time constraints and all these projects that are going on. I would love to just go around and for each person just to introduce themselves with your name, what city you're in, how you're involved in the project, and just a little bit about what you've done with the project so far. So I guess we could start with Dr. Coker, if you don't mind. We can introduce yourself.
No problem, Phil. Thank you for inviting us all on to talk with folks from the Brevard area. Being involved in this project is a real pleasure. I work with you and Jeff, and I'm looking forward to getting to know other folks like Elizabeth. But a little bit about myself. I'm an assistant professor here at the University of Florida. I do environmental epidemiology. I'm on one side of my brain here at the University of Florida. The other side of my brain is dedicated to teaching. And on the research side, so I do environmental epidemiology, which means I study how environmental chemical contaminants and even other types of contaminants like bacteria and viruses can affect human health. And so everybody's come to know what an epidemiologist now is in the era of COVID. I don't have to explain that necessarily, but yeah, this community engagement project is, something that I'm really committed to. I believe, one of the best pathways to address environmental contamination issues, especially with people that are impacted, is to work with those people directly. And so fortunately, EPA has funded us to be able to do that kind of work. And I'm happy to do that in collaboration with folks at UF and folks like you, Sel, and Jeff, and Elizabeth. So thank you for inviting us on to talk about this a little bit and have a conversation in the era of COVID. We can't do it in person, but we can do it in the format.
Dr. DeLees.
Hi, thank you for inviting us. So yeah, I'm super excited to be here, and I'm super excited also to meet everyone and hear the questions and collaborate more for the project. So my name is Catherine. I have a background in biology, so I know in ecology, limnology, know a little bit about the environment, water, soils, organisms. I did my PhD in environmental engineering though, so I also have kind of that intuitive approach to like finding solutions to solve some of these environmental problems too. So yeah, that's pretty much what I do. So most of the focus of my research is primarily in fate and transport of pollutants. That means like what happens to these pollutants when they go into the environment and they interact with soil and they interact with water under different pH conditions and under different like types of soil, under different weather conditions. How do they transform in the environment? And if that transformation makes them more able to bind and stay there and not move anywhere and not bioaccumulate and be uptaken by organisms and people, or if that makes them more available for uptake and in a way more toxic as well. So I kind of focus on understanding how pollutants behave in the environment and how we can prevent them from spreading and reaching out communities and in ecosystems at risk.
Rebecca.
Hello, thank you for inviting me. My name is Rebecca Shaw, and I am a current graduate student at the University of Florida with a concentration in environmental health. So I'm just kind of jumping onto this project as part of my internship, and I'm really excited to be a part of it. Part of my research is working on conducting a survey to gain a little better understanding of Brevard County's community and their environmental needs and perceptions. I'm also going to work on putting together some training videos regarding environmental sampling to help out with everybody's training. And I'm just really excited to be here. And yeah, that's who I am.
Elizabeth. You just want to say
Hi, I'm Elizabeth Baker. I pick up litter commercially on commercial properties. I went out a couple years ago and started to just do that on my own because I wanted some exercise, and I started to realize how bad the problem was. And then I started seeing people mowing over litter and realizing that we have a real problem here with how we dispose of our waste. And so that just kind of led me to finding STEL, to finding a lot of other environmental groups in Florida, and really starting to pay attention to what's really happening with our soil, with our water. And I just want our kids to have clean water in 20, 30, 50 years. So that's why I'm here.
Jeff.
Hello, Jeff Dubitsky, Vice President of Fight for Zero, and honored to be in the great company of everybody that's on this call today, and to have us announce and better understand for the community what's going to happen with these studies that we're involved in and how they can become involved and how they can help us fight for zero pollution and how that pollution affects everybody in the community's health and why it's so important for them to be involved. So just very grateful and excited to be here.
And I'll go ahead and for anybody that hasn't met me, I am Stell Bailey. I am the executive director and founder of Fight for Zero. And we came up with that because we believe that there should be zero pollutants in the air, water, and soil. And we know that it's connected to health. And I'd love for you guys to visit our website if you want to learn more about what we do and why we do what we do. I also have somebody coming into the live stream. Let me see. It's Kayan. How do I pronounce that?
Yeah.
Hi, yeah, it's Kayan.
Hi, how are you?
Hi, I'm good. How are you?
Good. We were just introducing ourselves, and I'd love to hear who you are and how you are involved in the project.
Okay. Hi everyone. I'm Kayan Clark. I am Dr. Coker's PhD student. I have been a part of the project since inception, and I'll be helping with collecting samples any way I can, as well as help to train community persons to do the sampling properly as well. And yeah, helping out any other way I can.
Awesome. So, one of the things that we want to talk to the community about today is just a summary of the project and what's been done so far in the last few months. I know that we went out and we sampled during Tropical Storm Elizabeth, and Jeff was out there with us, and we had a little bit of a trial and error, but we were trying to really start structuring and organizing how things are going to take place in the community so we can mobilize everyone to get out and do the sampling. So I'd really love to hear a summary from you guys about the project and what's been done, because there's been a lot that has occurred in just a short amount of time. So I'd love for the community to get an update on that.
Great. Catherine, would you like to start?
I can start, yes. So I guess let me start. I'm going to start from the beginning, okay? Like how we got into the project for the first. So EPA opened these opportunity, Environmental Protection Agency opens grants that you can apply for. There was a call, not specifically for PFAS, not specifically for Brevard or for Florida. It was just to better understand how environmental disturbances, like natural environmental disturbances like floodings and fires and hurricanes and all that, can affect the transport of pollutants in the environment, and how these changes, how this transport of pollutants affects communities. And a requirement of that proposal was that we needed to make sure that through the process, a community was gonna be benefited from it, right? It's not just like this type of research where you go do your investigation because you're curious about some questions and it's just about what you want to know. It was about helping communities. I mean, I've been working on PFAS projects in the past. And I've been interested in like the way that I approach research is more of a practical approach. I do want to do research that helps communities, that has like that practical immediate application, right? That can help us become more resilient. And when we say resilient, we mean that that we have this sustained or consistent ability to withstand and adapt and recover from different events. And it can be like COVID, it can be a hurricane, it can be losing power, water quality, so that we're able to recover from these disasters like very rapidly, because there's a strategy, there's mitigation and management strategies to address these things. With that in mind, and knowing that there was a concern with PFAS contamination in Brevard, it's been in the news, like we've heard about it, everybody's upset about it, right? We don't want this to happen. It shouldn't be happening. So we put together a proposal with the intention to understand like how hurricanes, because in flooding events, because it's a very typical natural disaster, an event that we experience in Florida every year, even if it's a little, or like we experience like storms or hurricanes or flooding events, and then to see how these events affect the existing prevalence of contaminants that exist in Brevard. How is it going to affect their transport? And then to better understand what's in there, because we understand that there's been some research that has been done. We know that they have detected PFAS in groundwater, but there's not like a comprehensive analysis of the environment. So we will be doing sampling of surface water, we'll be doing sampling of soils and sediments, we'll be doing sampling of fish, because we anticipate that all of these are potential routes of exposure for the community, and we want to understand like how can the community, depending on how the community interacts with the environment, how would these could be potentially a source of exposure for the pollutants. So with the different sampling that we're going to be doing, we want to know what is the occurrence and diversity, like how much of the PFAS are there and how many kinds of there are there. All of them, I mean, PFAS are like over 5,000 of them. Typically you find like about 100 and something in the environment. That's how much we can analyze at this point, like about 155. But they all behave differently depending on the length of their chain. Like this carbon, long carbon chains with lots of fluorine in it. And then this carbon fluorine compound makes that PFAS the forever chemical. It doesn't break down. It is very recalcitrant. It just lasts in the environment. It doesn't go away, but can be bioaccumulated, and it has it can potentially has health outcomes from these exposure to it. So by knowing which kind of PFAS are there, we would have a better idea of what are the potential for transport. Some of them are more able to transport in, like longer PFAS are able to bind better to soils. But then they can also bioaccumulate in animals. And then shorter chain PFAS tend to bioaccumulate more in plants, things like that. So by knowing what kind of PFAS are in there, we have a better idea where these would tend to bioaccumulate and what are potential routes for the community to get exposed to it, and what are the potential health outcomes that can result from exposure to those specific types of PFAS. As part of, in addition to understanding like what's in there, we want to also understand how the community interacts with the environment, and so that we have a very targeted solution. Like we know exactly what to expect from the environment and their exposure. So we're going to be developing a model that's going to help to predict under different scenarios of flooding or under different scenarios of like environmental disturbance, where do we anticipate are going to be areas of higher risk, and so that we can mitigate and plan not to go to those places or not to consume certain things during a certain amount of time until things get a little better. So this model will help us predict a bit better, like how to water potential exposure so that we can reduce those risks. Do you want to add?
Sure. I can jump in and maybe build from what Dr. Louise is mentioning, right? So obviously we have these important research questions, the extent of the PFAS contamination, what types of different PFAS chemical species there are, where it is, how much of the specific, so the concentration in the environment. Yes, we want to know about all that, obviously, and so do people in the community. We want to know how they get distributed. But kind of in doing that, what we help to do is to raise people's, the community members' knowledge of where these contaminants are, and if we know where they are and which ones they are and which kind of compartments of the environment. And so is it in vegetation? Is it in fish? Is it in water? And if we know where and what type of environmental compartment, then we can start to do resilience building activities. And what I mean by that is, one way to build resilience is to adapt to a certain situation and recover. And so, mind you, not everything should be put on the community to recover, right? If we know where the contaminants are, how can we recover a clean environment? Well, obviously, that's going to require, some sort of government intervention, some type of intervention, right? But on the piece of adapt to, I think that's where we could intervene potentially. And so we want to identify, and a key piece of this that didn't get mentioned was the vulnerability. So, we want to know which communities are most vulnerable to this combination of flooding risk and PFAS exposure risk. And so we believe our study will be able to answer some of those questions. And so, which communities are most vulnerable, but there's other types of vulnerability that people experience. People might be older, and so they're particularly vulnerable because their immune system is a little bit suppressed, which is something we've all become familiar with, through this COVID pandemic, right? There's also people who are elderly population. They might have comorbidities, underlying health conditions that make them particularly vulnerable. So, do we see these elevated exposure potential in those populations? It's a question to ask, right? Other vulnerabilities, social vulnerabilities. You have some people who have low income. They have low amount of wealth. They have poor access to quality health care. They have lower education levels. These are social and health vulnerabilities that we need to understand. Where are those people living? Are these the same people who are likely to be exposed to these flooding risks and these contaminant risks? And so this is a question that we are asking as a part of the study as well. And so I've done some preliminary work in that area. Is it, for instance, let's take a community like Titusville, which has some low-income minority population there, and they face some social vulnerabilities. We want to know, are those folks at increased risk of exposure? Because there's this idea of cumulative exposures, and therefore chemical contaminant exposure can make you more susceptible to some kind of negative impact, or it's more difficult for you to adapt because of your social conditions. And so we want, in those places where it's more difficult to adapt, we do want to identify those communities and how can we build more resilience in those particular communities. And so that's another component of what we're trying to do. We have 3 years to figure this out. It's not very much time. It sounds like a lot, but science and community engagement moves in like geologic timescales. And so because of that, we want to be as productive as we can. And despite COVID, we want to link up with folks like Elizabeth and as many people as we can. So that's a piece I want to kind of expound on a little bit, this vulnerability and the purpose of community engagement, one of the purposes, actually there's a variety, but is really to identify these vulnerable communities, work with them, play some beneficial role for these vulnerable populations. And so, yeah, so that's another, that's the other half of the study that kind of I'm leading, and Dr. DeLise is helping out, and have a lot of students supporting this work. Kayan, Rebecca, and Karen are on this call right here. And so, and then of course, Jeff and Stell. So that's kind of the team, I think, right? So yeah, that's what I'd say.
And I wanted to say that while EPA is officially funding, I mean, these analysis and the effort, we need funding to be able to afford like standards and maintain the equipment and purchase the bottles to collect the samples and all these things. So it needs to be funded. But while EPA is funding the investigation for 3 years, I do see this collaboration as a long-term collaboration where we can continue to work with the community to continue to track if like the strategies that we're recommending are working and how they can be tailored to just continue to build that resilience in that community. So it's not going to end. You're not going to stop seeing our faces after 3 years.
Yeah, absolutely. Thank you, Catherine, for calling that out. Yeah, so we have funding for 3 years, but certainly we want this to be a sustained engagement, and where the progress that we make collectively is goes well beyond 3 years. And so I just echo that. So thank you, Catherine.
So I think the community would be really interested in your latest sampling with the soil sampling. Maybe go over a little bit about that. I know Jeff pulled up on you in his van and he saw you out there digging in the sand and getting all those soil samples. And what exactly were those samples for? And how do you determine the locations that you're taking the samples?
Yeah, so I have the 2 people that actually help with that. So Karen Sam is one of our undergrad students in environmental engineering and science. And she put together a map in GIS where she identified, EPA has already identified certain companies or industries that are releasing contaminants into the environment. They do release some sort of contaminant into the environment. The ones the record for PFAS release is not yet out. That comes out, I think, is in June, July. Correct me, Karen, if I'm right, but I think it's this summer. So we kind of work assuming that we understand where PFAS is incorporated into, what kind of processes in the industry. So we anticipate that we might find PFAS in some of these industries. So identifying those places and also understanding a little bit of the hydrology of the site. So if it rains, where is the water moving? So because we cannot get inside of a lot of these facilities, be their fenced, but we want to know, so where around these facilities should we be primarily sampling? And then we're trying to focus on those areas where we anticipate sediment and water will be running off, and then just going towards that direction to capture the most of like of those releases into the environment. So we identify those locations in this map, and then based on the hydrology, we started just collecting as close as we could to these places. I have to say that the highlight of the day was actually the support from Jeff and Stell, because I mean, the way we see maps, and then once we get into the site, we don't have the same access that we thought we were going to have. So we're kind of like in the site and struggling, like, where are we going to sample now that's close enough that we're not going to be put into jail. So yeah, it was great to get support for you guys to let us know about the trench location where all these toxins were being put on and then capped. So the idea of these soil sampling, and we have collected some water samples as well, but we're focusing on soils right now because we want to understand if it's in water, it's because it was first in soil, right? It was discharged in the soil primarily, and then through runoff, it went into these water systems. So we want to know and identify what are the sources of it. Where are these potentially coming from? And then so we're trying to collect as close as possible to these source places. And then in terms of the trench, we know that waste has been disposed in there. We know that communities near that area experience higher than average health conditions. And we wanted to make sure they have capped the area. That means that in engineering, when a site is contaminated, there's different ways to go about it. It's not always economically feasible, and that's just what it comes to remove all the contaminated sediment or soil and dispose of it. So you're supposed to remove the top layers of contaminant, the really bad ones that gets put out, and then the rest gets capped. And that means that you're just putting a layer of sand or clay to prevent runoff from it, right? To just prevent that if it rains and it with the runoff, that those pollutants get transported through runoff. Another thing is the capacity to move down with the water into the groundwater. But at least the capping will take care of the runoff. So we collected samples. We don't know how deep the capping was. We collected like 5 inches deep, which in a typical soil will be a good portion of like that, that topsoil. And the idea is to see if there's PFAS in the surface, like near the surface of the soil, that will be available for uptake and transport through runoff to take to different water bodies. If we do not find PFAS in that upper 5 inches that we collected, because we know as a fact that is a site where waste and toxic waste was disposed, we might want to go and with a core sampler, it's kind of like a more of a tube that you put into the ground and go and take a deeper, and then we can kind of layer it in different, like every 6 inches, we'll kind of collect a sample until we see where exactly is where that contamination starts. And depending on the type of soil, if the soil has a lot of clay and organic matter, maybe the PFAS and other contaminants are more bound into the sediment and don't tend to leach out. But if it's really sandy, which is most of what we actually saw when we went to site, then there's not much in there to bind to. So most certainly, if there's contamination in sandy soils, they will tend to infiltrate to groundwater or just run off. So again, the idea of collecting these soil samples is to know potential sources, collect near what we anticipate could be potential sources, and that include landfills, that include wastewaters, that include industries and factories that produce certain chemicals, and see if near those sites there's a higher risk because they're kind of bleeding out and through runoff being exposed into the environment. And then also to get a little bit more information about what type of soils there are in there, because depending on type of soils and the characteristics of the soils is how those PFAS will tend to either stay in place or move elsewhere. And then in addition, while this is focused on PFAS, I also want to say we're analyzing for other things. We're analyzing for trace metals as well, because they can also fight, those metals can also fight for binding sites into the sediments. So if there's other co-contaminants inside, that might, you want to know, like, what would happen? Will the metals be leached out because the PFAS are the ones that are winning the fight to stay bound into the soil, or would the metals will bind and then you will have PFAS running on, because there's so much co-contamination and other contaminants present in there as well, not just the PFAS. And understanding that with co-contamination as well, could be a higher toxicity because you're not only getting PFAS, but you also might have other things in it.
Can I just clarify some things for the community that I heard you say?
Yes.
And tell me if I'm wrong, if I heard this wrong, or if this is a misunderstanding. What we're talking about, the samples that we're collecting, is not because of PFAS found in sunscreen, cookware, that type of stuff. When we brought this up in the community before, we had the pushback of, well, it's in everything. It's on your carpet. We're not talking about that. We're talking about much higher amounts in designated areas that we know have been contaminated beyond safe levels, for example. Okay.
That's
and
correct.
then we know that that travels across the street. It doesn't
Yes.
stay at one place. It could become airborne. It could go into the soil, and that it actually travels. And the study is showing us in the community how it travels, why it travels, if it goes into the air, if it's deeper into the soil, because we already have the test results that show it's in drinking water, it's in groundwater. Other organizations have tested the marine life and they found it there. So we're trying to understand all that. But it's not just because you've used cooking ware or a sunscreen. This is not that at all.
No. And I mean, and there's going to be exposure. Yes, we all have. I have PFAS. I'm afraid of testing how much I have. All these like wrapped up impermeable things and impermeable jackets that you wear. Even the cars, the car seats. I mean, it's everywhere. But what we're looking for is higher exposures, because again, we are exposed throughout the US, throughout the world. We're all exposed. We don't have these above average health conditions that we are seeing in Brevard. So what is different there? Why is it happening in there? And what we anticipate and what we believe is that this is definitely coming from the environment, from the drinking water, and it's in the drinking water because the groundwater was contaminated, and the groundwater was contaminated because soils and sediments got contaminated because these waste was discharged. So yeah, we're definitely looking for that. And even if a site is contaminated and it's fenced, soil doesn't stay there. It doesn't stay there. When it rains, you're gonna have sediment transported. And it's gonna keep transporting, and with more rain and with wind and with all different types of weathering, it's gonna be transported and transformed a little bit until it just doesn't change anymore. It just stays there forever. But it can keep moving in the environment. It can be uptaken by plants. Animals can eat the plants. It can be uptaken by fish, as you said, and then you can be eating the fish. So which fish have the highest concentration?
And bioaccumulate means it builds up in a person's body and eventually can, and in some cases had made them ill.
Yes, bioaccumulation means exactly that it's building up in one body. Biomagnification will be more like it's in a plant, the fish ate the plant, now it's a higher concentration in the fish, then I eat the fish, then I got a higher concentration because there's all that chain of accumulation. So yeah, we're trying to see like where is it at higher concentrations, if there's specific fish species because of their eating habits, some are bottom feeders versus like filter feeders in the water. So depending if the contaminant is primarily in the sediment versus if it's in the water, and those feeding habits that fish will have, we can see that there might be a trend on like which are higher risk of eating because of PFAS exposure if you consume those type of food. So those are the type of questions that we're trying to answer when we're monitoring the environment.
Can I make a couple points real quick? First off, just like it's so awesome to have an environmental engineer sitting at the table with us. And this project really is multidisciplinary and multi-sectoral, right? Academia, nonprofit, community. She brings up a lot of points that I would not be equipped to bring up. So I really admire that. But I want to come back to the point that Jeff made, and I really want to crystallize it a little bit about, people can often be disingenuous when they say, but it's in sunscreen or it's in, yes, of course. Okay, it's in that stuff, right? But there's two different types of, in environmental health, we look at two different types of chemical exposures. There's ambient exposures, and there's like what you encounter in the ambient environment that you have very little control over. And then there's personal exposures, which are determined by your personal daily habits. What sunscreen do you put on, right? So we're not talking about landfills that are exclusively pots and pans and sunscreen landfills, right? We're talking about landfills that have receive a lot of different things that have these PFAS contaminants in them. We're talking about former DOD or current DOD sites that have or airports that have used these used products that are heavily contaminated with or purposely included these contaminants, right? So ambient environments, that's where the government actually really is, that's what they're responsible for. And the people that pollute the ambient environment are responsible for cleaning that up as well. So what we don't want is a tragedy of the commons where, you know, the soil, the air, the water that belongs to everybody, including the animals and the plants and the people that are all interconnected. We don't want a tragedy of the commons where we just say, oh, it's up to your personal behaviors, that will solve the problem. I mean, it won't. Okay, if we put a ban on PFAS completely, that solves one half of the equation. What about the legacy of historical contamination that's been happening for decades? That needs to be addressed. And so it's really off-putting and disingenuous to say, well, you know, just worry about what sunscreen you're putting on. That's not the full story. And so I hope that we can tell the full story, at least write a chapter on that piece of it. So just wanted to crystallize that point a little more.
I do have a question, if you don't mind.
Yeah, absolutely.
Okay. So in my trash picking adventures, I noticed, you can't help but notice when you're doing it, county, FDOT, mowers, and even just your regular landscapers out on normal people's properties, mowing over trash. Where I have noticed, you know, a large amount of this happening is along the roadways in Brevard County, which we have so many miles directly on the water. US 1, 528, 520 specifically, just because that's kind of my stomping ground there. I kind of dug into it a little bit and realized that number one, a lot of the mowers are under the impression that they are not required to pick anything up that is smaller than a soda can. That came directly out of somebody's mouth to me. And I've seen them mow over bottles of motor oil, 5-gallon buckets, mattresses, even, you know. So even the small things that are there are getting run over, plastic bottles, and this is weekly. You know, during the summer months, obviously they're mowing more and less during the winter, but it's definitely at least 2-3 times a month that the mowers will come through on the county or the state roads, mow over the garbage, leave it behind. And, you know, I know that when you're breaking anything down physically like that, you're speeding up that process by which plastics would become microplastics and thereon. And so specifically when I'm talking about, you know, 528 and 520, those contracts have been in place for a very, very long time, written exactly the same way they were, you know, like 50 years ago. There is no separation of the mowing versus the litter pickup. So these guys, I don't mean to put all the heat on the mowers. They're dealing with time constraints. They're dealing with their bosses yelling at them. They're dealing with car accidents and everything else that it's happening. But, you know, 50 or 60 years of weekly going out and mowing over trash directly on the water, I have a hard time believing that that's not related to chemicals from plastics and getting into our water. So, you know, I don't know if that's something that you guys have looked into. I don't know if that's any part of even on the radar right now. But, you know, from what I have seen over the last few years, it's just unimaginable to me that the high levels of plastic in the Indian River Lagoon have nothing to do with that, because I mean, they've been doing it the same way for a very, very long time, right up until currently today. So, you know, I don't know if you have any input on that, but I would love to hear.
I can jump on that one. So it is definitely outside of the scope of this project. I do have my interest in that type of research. there's a lot of things that come with these microplastics that I would be concerned about, not only like the chemicals that they release, and I mean that they will be consumed by marine life, like and sea turtles and fish and birds. I mean, you will see these things in their guts if you open them. But they are also like a surface to for other microorganisms to bind to float and be transported elsewhere. So there might be bacteria that's in there. There might be other pathogens and things that can hold on to those as a substrate to linger. So it is of concern. I am surprised actually to hear that they think that a soda can is small enough that you can just mow over. It's I think that's large, and it will definitely speed the breakdown process and whatever decomposition or release of chemicals and metals that may come from whatever waste it is. And this is I'm also part of a different project, not this particular. It's also related to PFAS, and it has to do with understanding what type of PFAS come from different types of waste. And we're talking about it can be construction waste, but it can also be municipal waste, so like just food wrappers and things like that. And it's still in the process. We don't have these full results right now, but we will be investigating a little bit more about what type of PFAS, what type of products release what type of PFAS, and how easily they get leached out of these products into our skin or into the food that you're eating and things like that. So that information, I mean, will be published, and it will be adding more to help us understand and create a bit more of that personal habits management. Is like, do I want to expose myself and use these, or would I rather use these other products, kind of thing. So talking a little bit about what Eric was mentioning, that there's decisions that you can control, right, about the environment, and then there's those things that you can control. So if we provide those types of information, then the community will be able to make those informed decisions about what level of exposure they're comfortable taking under their each personal situation. I would be more interested in talking to you about maybe potential studies that we can do with microplastics in the area, not for this particular project, but perhaps something that we can investigate a bit more.
Yeah, I would love to be able to help any way that I can. It's like I said, I can't imagine that the two things are not related.
This is the type of information that we need to, because there's so many research that we do that requires long-term studies, because we're not there. We don't know every site, but the community is there. I don't need to be there long-term to get certain kinds of information, because the community has lived there long-term. There's a lot of information that we can get from the community to better guide these research questions, and like what really is important, what we really need to be looking into. So all of this information is very useful for us.
Wonderful. Thank you.
I agree. We do have some questions from the community. One of the questions is, well, when should we expect to go out and take samples? We've had people sign up to be citizen scientist volunteers, and what that is they're volunteering to basically go out and take these water samples or soil samples. And we definitely still need more people in certain areas. So I'll put our website below, so that way everybody can go on there and sign up if they haven't already. You'll be put on a special email, and you'll also get a newsletter and communication directly from the team. But I would like to talk about when they should expect to go out and take samples.
I think I'm looking forward to summer. This is like what I have in my mind. And the rationale behind that is that that's when the rainy season starts, and we're going to see a little bit more of these activities that we're concerned about, but also because it gives us this first year as an opportunity to do a screening of the area. So we don't know yet what concentrations are near all these potential sources that we identified. So the idea is, like, once we test this and we know the actual concentration, we're going to focus on those sites with the highest concern and the higher probability for community exposure. We can sample like 100 different sites, right? So we'll have to pick like a good, I don't know, 25 or 30 sites that we understand that these are the sites that we need to be paying attention to. So this first year screening for us to collect samples and just screen the area, understand what's in there, at what levels are in there. And then once we have that information, we will know exactly which are the sites that we're going to be continually monitoring for a couple of years.
Yeah, so maybe just, there are kind of like three fronts that we're working on where people can participate. So there are these storm related events, which obviously, are unpredictable to predict, 3 months from now. But, obviously within the span of a couple weeks, we can know, or well, if it's a hurricane, we can have some idea within a couple weeks. Within 5 days, we can have a pretty good idea for a tropical storm that it might come to this area and we need to mobilize. So that part of it is a little bit unpredictable, and is totally dependent on seasonality. But there's two other fronts where I think there are kind of opportunities. And so there's drinking water, which is an initiative that I know has been going on in Brevard for a while, but Estelle has indicated that there are folks who want to understand this problem a little bit better. And so that's another front where we're trying to tackle, strategically looking across different communities, which communities seem to be most impacted by PFAS contaminants. So we are collecting samples from community members. And so Estelle's been given some equipment and some guidance to kind of execute that front. And then another front is the fish contamination. I mean, people are fishing almost all year round. And so, if you're a fisher person, I don't want to see fisherman. If you're a fisher person, then, please let us know, let Estelle know. There are drop-off points. We're working with another organization called Orca. They have a great citizen science system in place where you can drop off your fish sample that you caught from Indian River Lagoon, or maybe it's one of the nearby lakes or the rivers. There are plenty of water bodies that primarily in Indian River Lagoon, I would say, but where you can go to these bait and tackle shops, and there are drop-off spots for your fish samples. Orca will collect them, process them somewhat for us, send it to our lab, and we'll analyze those. And so we really are looking to do a multimedia, multi-pathway of exposure understanding of the problem, from the ambient and personal exposure. Your drinking water, that's a really interesting one because you don't have much control over what's in the drinking water. There are some things you can do, like applying filters that can be really expensive for people that are low income. There are things you can do, like drink bottled water. Who wants to drink out of plastic bottled waters? I don't. And it's also very inconvenient. So people might say drinking water is a personal choice. That's true for people who are privileged and don't mind drinking out of plastic that has other types of contaminants leaching into it. And coming back to this point of plastics, I think there was a big lie told to the American population about plastics. There was this myth put out by the oil industry that somehow all of these plastics would be recycled and will not contaminate the environment. We now know that a very small fraction gets recycled. And if a small fraction is getting recycled, where is it ended up? A small fraction is ending up in landfills, and the rest is going out into the environment. So we don't want people choosing bottled water. We know where those bottles of water are going to end up. So so that's another front, is drinking water, fish, places where you all can contact Stell and you can contribute. But with respect to the water sampling, surface water sampling during storm events, what I think at this stage we're not so comfortable with folks in the middle of a storm and immediately after a storm collecting a sample. We think that there's kind of unnecessary risks you're putting yourself at. So what we are hoping for is, we have the meteorological, people who do meteorology, that magic, that they somehow figure out how the storm is coming through all those spaghetti plots. Once we know a storm is coming, we hope people can mobilize and collect samples before the storm hits. That way we can get that short-term acute effect of the storm events. And then Dr. DeLees is looking over time, over a longer time scale, how these pollutants are changing. But it's interesting to know before the storm hits, right before, during, and after. We want to know like what's happening in those immediate time periods. But please, we don't want folks going out in the middle of a storm and putting their kids or themselves at risk or a loved one. And even after a storm, there are maybe there's down wires and people get electrocuted. We don't need those kind of risks being taken. So it really is that pre-storm sampling we hope that people can mostly participate on. I just want to be clear on that piece of it.
Yeah, I agree. Safety first for sure. And us as a team as well. I mean, I'm going to the field, but we're bringing students with us. So we need to make sure that they're safe as well. So yes, like as close as we can, let's say that we're collecting in a specific place and we want to collect as close as possible to that place in the during or after. But if it rained too much and the area is flooded, we're not just going to go swimming to get to that exact coordinates. But we're not going to do that. It's the same water. It's just a little bit skewed to the side. That's all. So we're just collect as close as possible where it's safe. Community, I mean, it's always welcome to see us participate and do these things and assist as they can. But yes, primarily before the storm comes, and will really help us. And then that way we can follow up and don't need to be traveling like every day there. Like there's a team there supporting the initial efforts, and then we can follow up and do the consecutive ones and collect all the samples and bring them back.
Yeah, maybe just, we had that kind of dry run when we had that storm hit, and I think in November, and we figured a lot of things of like what's going to work and a lot of things of what's not going to work. And I think there was a video posted on the Facebook, and I saw it. I was like, maybe we don't want people wading around in floodwaters, trying to get samples that like contaminated water. I was like, we should balance this a little bit better. But I appreciate that video though.
I'm glad I was the guinea pig on that because I was the one out there in rain boots doing it.
Yeah, I mean, we all want our Erin Brockovich moments, but gotta temper it a little bit. No, just kidding. So, but good on you, Stell, for doing that.
One of our number one questions, and I know this is going to be repeatedly asked, and I know that you touched on it a little bit. People are going to want to know, when are we going to expect the results, the test results? People are always interested to know what you're finding. So kind of gives you an idea of how to expect that to.
Yes.
Yeah.
So
I think Catherine can answer that messy answer. So.
Yeah, it's not as easy to get there, and then there's an availability to the equipment too that we use to analyze our samples. There's like other projects running and that are kind of like in line to get first, so once we collect the samples, just like we collect the samples are frozen, and then once we get into the lab, the samples need to be processed to extract the PFAS from it. We just don't put the sample as it is in the machine. We have to, and then there's different extraction processes for the sediments. There's different extraction processes for the water and for the fish. It's all different, all done at different labs. And the extraction process alone takes a few days because we can only do so many samples at a time. For like water, for example, we can do like 28 samples in a day, and it's a full day, like 8 a.m. to probably 6 p.m. Like you're just running those 28 samples through different steps until you extract all the PFAS and have the sample that is actually going to go into the machine. But the machine is not going to be turned on to run 28 samples. The machine gets turned on to run hundreds of samples at a time because it's more cost efficient. So we spend days processing samples, and then when enough samples are accumulated, then they're ready to run. And you don't need to run just water samples separate than soil. So we're processing water samples, we're processing soil samples. Those are a little bit easier than water, but also take their time. We can only do 14 samples per day. They go, I mean, quicker, but you can only do certain numbers just because of the equipment only allows to put certain number of samples at a time to do all the steps. And then fish is a little bit more tricky. So we're in the process. So it takes days, a couple of weeks typically to just go through the samples, just extracting the PFAS from it. And once we have enough samples and they're put in the machine, it takes days for the machine to run. One sample alone, the machine looks at it for 30 minutes. So, and there's a sample, so there's hundreds of samples that are gonna be there, but there's other samples that are quality control, and they're added to make sure, they're included into the batch of samples analyzed to make sure that we did everything well when we process the samples. It gives validity to our results. So it shows that we did it right because our quality control samples give us the correct results. Our blanks were clean, our spikes were what they were supposed to be. So that analysis, just running in the machine, will take a few days. And then the machine doesn't give us numbers. It just gives us graphs with peaks. And then we need to sit down and match those peaks to what they are supposed to be. And it requires a really trained eye to do that. So the more trained, the less amount of time that it takes you. So just processing the samples it could take a couple of weeks as well, just looking. And the reason that, it's a good thing, but it takes more time. So because now we are able to analyze 155 different types of PFAS. So if they're there, if those 155 are there, we should be able to identify them. It takes longer to scan each of those peaks to match it to one of this. Could it be one of these 150? And if they're not, but they're still a PFAS compound, then we will have to go around to identify. It will be a non-target analysis. We're not matching it with a standard. We're just identifying it separately, and that takes a bit more time. And that will be done by John Bowden. Dr. Bowden is the expert. He's the one that runs the machine, and it's the guru of PFAS. So that will take additional time. So the process is going to take like over a month just to go over the sample, just to process the samples, to put them in the machine, analyze them, and then process and see the data. I am hoping to have some preliminary results of what we've already collected by April, at the beginning of April, hopefully.
Yeah, so
but we'll keep you posted.
yeah, there's 4 and possibly 5 bottlenecks. There's the extraction, there's the availability of the instrument,
Mhm.
there's the running of the sample, and then there's the analyzing the peaks. And then the one that can really throw everything off is a contamination issue in the lab or an instrument going down. So that could be the 5th
Yes.
bottleneck that makes everybody freak out. So it is a process. It's multiple processes built on one another, and so it's a little bit messy. It's not a commercial lab, so you can't say, "Here's my $1,000, give me my samples." But John Bowden works pretty hard, and there's a lot of demand for his skills and expertise. So
Yes, and it happens because we don't know. These samples are all unknown. We don't know exactly how much we're gonna get in there. If any of these samples are really high, it just floods the machine, and then you need to take a break and clean it and let it breathe, and then dilute and do a little bit of something else. So it's happened. It actually happened in December, January. One of the samples was way too loaded, and then not one of our samples, but yeah, we had to wait a little bit until the machine was back up and running and clean, and we could rely on the results that we were getting.
Well, I think that concludes all of our questions. I don't see any more on Facebook. And I just want to thank you guys again so much. This went over a lot longer than I thought it would, but it was full of so much information, and the community is going to really, really appreciate it. There's, I think everybody's really excited to start taking some kind of action. I think they want to be involved and they want to make a difference. And this is one way that they can definitely do that, is by helping take samples. I already went ahead and put in the comments below where you can apply to be a citizen science. Really, you just have to put your name, your city, your email address, and your phone number so we can contact you and put you on our email server so you can get up-to-date information on, when they're in town to sample. Like they said, they're, go see what they're doing, check it out, and just keep you guys updated. So Dr. Coker, yeah.
Yeah, no, I want to put a plug in for Rebecca Schall's survey that it's kind of it's not associated with the EPA project, but it's similar in some ways. And so if you live in Titusville or you live in Melbourne, we are interested in finding out your opinions and knowledge about PFAS and other environmental contaminants, and what are you concerned about? There's some reasons why we're interested in those communities. I won't get into all that, but Stell's going to announce that at some point, and so just keep your eye out on that. So, thank you. Got to plug something, so, okay.
Yeah, and once we have those training materials that will be available to keep seeing, we'll also be in the field to do some of these trainings face to face. Things get a little bit safer too, but then there will be these training materials that will stay there that the community can continue to go for reference and when the time comes. So we're looking forward for that as well.
Yeah, and we'll have more virtual meetings like this on Zoom and even public on live. And like you said, you mentioned training, and I'm hoping that we could do a live like this to kind of go over training on a Zoom virtual meeting, because I know a lot of the community members, when they come out, they get a little nervous about taking samples, which I don't blame them. They want to make sure they're doing it right, that they don't mess up the sample. And so I think just going over that ahead of time, it's a learning process, but it's so worth it, gaining that knowledge and knowing how to go out in the field. And it feels very empowering to know that you can take this situation, take it back, into your own hands, and being able to take those samples and knowing that you're making a difference for future generations, right? So,
amen, sister.
Yeah,
right.
we really want to do that for sure. Yeah, so nothing to be scared about the samples, but we'll definitely give trainings, and what they need to think is that the most important thing is to be consistent. So we just want to make sure that for them to be comparable, they just need to be consistent. So the reason that there's a method is so that everybody does the same thing when they're collecting their samples. But it's really hard to mess them up. So in that part, they should be.
No pressure.
No pressure. All right. Well, I hope everyone has a great night and a great weekend, and we will talk soon.
Okay. Thank you.